Lesson 1.3, definition of trigonometric functions. This paragraph here discusses this picture. I've drawn an angle in standard position. I've dropped an altitude from the terminating side of the angle to the x-axis. This should be a straight line that makes a 90-degree angle with the x-axis, which turns this angle has now turned into a right triangle that's in standard position. The angle theta is the one closest to the origin. This line here, if you were to rotate it all the way around, it'll make a circle, so this is called the radius. This is also the hypotenuse of the triangle. Hypotenuse, because it's across from the 90-degree angle and it's the largest side. If theta is our reference angle, then the side opposite would be this V that we've labeled it. And the side adjacent, the side touching theta, U, is our adjacent. So we're going to define these different ratios, these trig ratios. Sine, which is abbreviated with an SIN, sine of the angle theta is the opposite side divided by the hypotenuse. Which in this case would be V divided by R. That is sine. Cosine, which is abbreviated as COS, cosine of theta, equals the adjacent side divided by the hypotenuse. In this picture, that'd be U divided by R. Tangent, which is abbreviated TAN, is the opposite divided by the adjacent. In the picture, that would be V divided by U. So to remember, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. You can remember SOHCAHTOA. Sine opposite hypotenuse, cosine adjacent hypotenuse, tangent opposite adjacent. Now, we have three more trig ratios, which are just the reciprocals of these. Reciprocal just means you're going to flip it upside down. So cosecant, its abbreviation is CSC. Cosecant of theta is 1 over sine theta, which is hypotenuse over opposite, or R divided by V in the picture. Secant is abbreviated SEC theta. That's 1 divided by cosine, or cosine upside down. So hypotenuse divided by adjacent. In the picture, R divided by U. Cotangent, which is abbreviated COT, is 1 divided by tangent, which is tangent upside down, adjacent divided by opposite, which is U divided by V. In example 1, we're going to start by plotting this point, and then we're going to find the 6 trig functions of theta. So you plot that point just like a normal ordered pair, -4 on the x, so left 4, +5 on the y, up 5, and plot your point. The point -4, 5. Now we're going to turn this into an angle. This is a point on the terminal side of an angle. So we're going to connect it to the origin. Always connect it to the origin. Now the angle is actually this angle here, but we want to look at the reference angle, so the one closest to x. So we're looking at this angle inside. We're going to label that angle theta next to the origin. We're then going to drop an altitude from the point down to the x-axis and create a 90-degree triangle. So we are talking about this triangle here. It should always be a right triangle. The reference angle is the one in the origin. So now we're going to label it. We should know the lengths of these. We can even count. This is 4 units. We're going to put a negative with it. This is 5 units up. So the altitude is 5. And then the radius we need to find. Since it's a right angle, we can use Pythagorean theorem, which is a squared plus b squared equals c squared. So in this case, we're going to have negative 4 squared, 5 squared, and we're looking for the radius. A negative times a negative is a positive. Add those, you get 41. Take the square root. We're just dealing with positive measurements, so I don't need to put a plus or minus because we're talking about the radius, which is positive, always positive. So radical 41, and that does not break down at all. So we're going to leave it as that. We drew the picture. That was just the first part. Now we're going to find the 6 trig functions of that picture. So we're going to start with sine of theta. Sine of theta is the opposite 5 divided by the hypotenuse radical 41. Cosine is adjacent over hypotenuse, negative 4 over radical 41. Tangent is opposite, which is 5, over adjacent, negative 4. Now, the only problem with what we've written is that you can't have a radical in the bottom. So we need to get rid of it. We need to rationalize the denominator. So we're going to multiply by the exact same radical on top and on bottom, which will give us 5 radical 41 over, this just cancels your radical. You get 41. Multiply by radical 41. That gives us negative 4 radical 41 over 41. So that's sine, cosine, and tangent. Now they want all 6. So now we're going to find cosecant, secant, cotangent. Cotangent, it's easy, just flip tangent upside down. So negative 4 over 5. Secant, you flip cosine. Now, I don't want to flip the final answer for cosine because that just puts the radical on the bottom. I'm going to go back before I moved my radical and flip that. So negative radical 41 over 4. Cosecant, go to your sign before you flipped the radical to the top and go ahead and flip that fraction. Radical 41 over 5. Signs of trig functions. Sign meaning positive or negative. So when are the trig functions positive and when are they negative? You can remember all students take calculus. That is a way of remembering what is positive. So A stands for all. All are positive in quadrant 1. It's quadrant 1. Quadrant 2, S stands for sine. Sine is positive in quadrant 2. Quadrant 2. This is quadrant 3. T stands for tangent. Tangent is positive in quadrant 3. Quadrant 4. C stands for cosine. Cosine is positive in quadrant 4. And so sine, or all, would mean sine, cosine, tangent, and the reciprocals, cosecant, secant, cotangent. They're all positive there. Sine means sine and its reciprocal cosecant. Tangent means tangent and cotangent are positive. Cosine means cosine and its reciprocal secant are positive. So that's how you're going to remember when it's positive. Example 2, a lot like example 1. They give you one answer, they tell you what quadrant, and they want you to find the rest. So quadrant 4, now we know where to draw it. Vertex at the origin, initial side on positive x, and then we're going to terminate in quadrant 4. We're going to drop an altitude up to the x-axis, turn it into a right triangle. We place theta next to the origin inside. So that's how you start. It says the sine is negative 1/4. And we know that sine is opposite over hypotenuse. So that tells me that the opposite of theta is the 1.